If a 0.01 molar solution of caproic acid, a monoprotic acid thought to be at least partially responsible for the unique and generally considered foul smell of goats, has a pH of 3.43, calculate both its Ka and pKa. So for the acid, we'll designate it as HA, where it will dissociate to give you H plus H minus. Because it's a weak acid, we'll use an ice table to document its change in equilibrium. So the initial concentration that we start off with is 0.01, put negative x, and its equilibrium will be 0.01 minus x. The initial concentration of H plus is 0, same with A minus, the conjugate base. It would be positive x for the change, leading to x at equilibrium. So because we're given the pH value, which is equal to 3.43, we're able to find the value of the concentration of the hydronium ion, or H+, which will be equal to the value of x here. So remember that pH is equal to the negative log of H+. And anytime when you're given the pH, you can work backwards in order to find the value of H+, where H+ concentration is equal to 10 to the negative pH value. So 10 to the negative 3.43 is equal to 3.72 times 10 to the negative 4. The equilibrium constant for the acid will be the concentration of H plus times A minus, the conjugate base, divided by HA. So we can go ahead and plug in the values from the ice table into our expression. So H plus will be x, A minus will be x, and HA will be 0.01 minus x. But remember, we found the value of x based on the pH value that was given in the problem. So x is equal to 3.72 times 10 to the negative 4. So we can go ahead and input that value into our equilibrium constant. So it will be equal to 3.72 times 10 to the negative 4, 3.72 times 10 to the negative 4, 0.01 minus 3.72 times 10 to the negative 4. And that gives a value of 1.44 times 10 to the negative 5. So in order to find the pKa, we'll use the Ka value. Where pKa is equal to the negative log of the Ka value. So negative log of 1.44 times 10 to the negative 5 is equal to 4.84. And that's the answer. Please subscribe to my channel if you haven't done so already, and thanks for listening.